Hello everybody. Today we're going to do notes about dimensional analysis, which is a fancy way of saying that we're going to convert units from one type of unit to another. So in math class we learned that you can cancel things. So if you have one on top and one on the bottom, that they can cancel. So on the left you can see 1x on the top, 1x on the bottom cancels out, and it leaves you with just y. Units are the same way. We have to make sure that we cancel units out. So if I have centimeters cubed on top and centimeters cubed on the bottom, one of those cubes is going to go away. The one on the bottom is going to go away. 15 divided by 5 gets shrunk down. Then we end up with 3 centimeters squared because one of these centimeters got taken away. This idea that you can cancel units just like you would cancel out variables in a math class is what's going to allow us to convert our units. So we're going to call the things that we use to do this conversion factors. It's going to be a relationship that sets one thing equal to another. And we're familiar with these already for kind of everyday type measurements. Like 12 inches is 1 foot. Or maybe 24 hours is 1,440 minutes. 1,000 meters is the same as 1 kilometer. So these are equality statements, right? This measurement is the same as this measurement. Even though the numbers look different, they're measuring the same quantity of something. We can rewrite these as fractions. If I divide both sides by 1 foot, I end up with 12 inches over 1 foot equals 1. If I divide both sides over here, I end up with a very similar type fraction. And same over here. Because this statement is the same as saying 1, I can multiply something by this fraction, and I'm not really changing the quantity. It's like multiplying by 1. Anytime you multiply by 1, the number stays the same. So what's going to end up happening is our quantity, our measurement will stay the same, but our number and our unit will look different because we're going to be converting it into a different format. We can flip these factors because we could have divided by the other side. The way you decide which version to use just depends on what you're trying to do. So I could write this 12 inches over 1 foot or 1 foot over 12 inches. 24 hours is 1,440 minutes. That's the same as saying 1,440 minutes is 24 hours. So it doesn't matter which way you write them. You're just going to flip them so that they're going to be set up the way you need them to be. We're going to use these conversion factors, and we're going to make use of the fact that 1 unit on top is going to cancel with 1 unit on bottom. So if I have 85 inches and I have 12 inches down here, these inches cancel out, and I'm going to be left with feet as my final unit. And when I punch this into my calculator, 85 divided by 12, out comes my final number. This number is exactly the same measurement as this one over here. 85 inches is the same as 7.1 feet. All I've done is I've chopped it into different size quantities, so my number and my unit looks a little bit different. One thing that's kind of nice is that you can use multiple conversion factors. Sometimes you may not know how to do the conversion in one step, so you may need to string them together. An analogy that I like is a frog hopping across a pond using the lily pads. The frog can't hop across in one giant leap. It needs to take little baby leaps to get there. So we're going to use our conversion factors as little baby steps. So for an example, if I want to convert 3.6 miles into centimeters, I personally am way too lazy to memorize how many centimeters are in a mile. I just don't have time for that. But I have over the years memorized some of the conversion factors that I use more often. Or maybe you have a list of conversion factors that you can look at. So what I'm going to do is I'm going to find conversion factors that lets me baby step my way there. I'm going to start with my known value, which is 3.6 miles. And I'm going to say to myself, what's one baby step closer to centimeters? Well, I can go from miles to feet. If I want to get rid of the miles, it's on top right now, so I need to put this piece of my conversion factor onto the bottom so that it cancels. Now miles there and miles on the bottom cancel out. If I were to stop right now, I would be left with feet, which means I'm not finished yet. So one baby step closer would be feet to inches. Well, I want feet to cancel, so I got to put that part on the bottom. One on top, one on the bottom cancels. If I stopped now, I'm not quite finished. I have to go one step further, inches to centimeters. Inches needs to cancel with that one on the bottom, and then we're left with centimeters on the top. Now you can punch this into your calculator. Be very careful that you're using parentheses or that you're paying attention to the order of operations. It might be a little bit different depending on which brand and model of calculator you use. On the calculator I like to multiply all of the numerators and then I divide it by everything on the bottom inside a set of parentheses. It's up to you how you want to use your calculator. If you're having calculator, issues, let me know. Part of the course is learning to become comfortable with your calculator. So it does matter that you know how to use it and that you can punch in the buttons and get the right answer. So please make sure that you are actually getting final answers on all of your problems, since the calculator portion is part of the practice. I'm going to just wait for a moment and let you punch those numbers in your calculator. If you feel like you might need more time, just press pause. So if you punched it in your calculator correctly, you would find out that 3.6 miles is the same as saying 5.8 times 10 to the 5 centimeters. The number looks very different. It looks like a much bigger number, but that's because the centimeter is a very small unit. It's a tiny little increment. A mile is a huge distance. So it's going to take a lot of centimeters to equal the same length. All right, time for you to try one. We're going to use some everyday units that you should hopefully be familiar with. I'm going to ask you to convert from 15 years into minutes. So how many minutes is the same as 15 years? I'll wait for a moment. You can pause the video if you think you would like some more time. And in a moment, I'll put the answer on the screen. All right, so for me, I think it's easiest to go from years to days, days to hours, and then hours to minutes. So the way I did this problem is I said, well, 15 years is my starting value. That's my known value. I know that 1 year is the same as 365 days. 1 unit on top will cancel with 1 unit on the bottom. I know that 1 day is the same as 24 hours, so a day on top can cancel with a day on the bottom. 1 hour is the same as 60 minutes, so hours on top cancels with hours on the bottom, and that would leave me with minutes. I'm going to take a moment and kind of mentally think to myself, okay, let's mentally check our answer real quick. I know a minute is a smaller unit than years, which means my final answer should look bigger because it's going to be a lot of minutes inside a year. Okay? So now let's double check that all our units cancel because that's another way for us to check our work. Years on top, years on bottom, days on top, days on bottom, hours and hours, and I'm left with minutes. I'm going to punch this in my calculator, and out comes my final answer. Sometimes people will ask me, does it have to be a 1 on the bottom? Do you need a 1 on the denominator? No, that's just a coincidence. If we were going the other way, if we had a different combination of units, if we were trying to convert to something different, if we knew different conversion factors, then we may see different numbers on the bottom. So that is only a coincidence. It's not on purpose. All right, next I'm going to show you a way to do the same exact problem, but we're going to show our work a little bit differently. We're going to show our work in a way that a lot of chemists tend to do it. It's called the line method. It makes things a little bit tidier. Instead of looking like a bunch of fractions in math class, it's really going to help draw our focus towards the units because that's what we're really caring about. We're mainly focused on changing our units. So here's the exact same problem from the previous screen. I start with my known value. What I'm going to do is instead of having a multiplication symbol, I'm going to put a vertical bar. This is going to end up looking like a series of little boxes instead of a series of a whole bunch of fractions. And you would be pretty surprised at how much space this method saves you when you're doing some pretty long problems. The other reason this method is helpful is sometimes our conversion factor might have scientific notation, and then your numerator or your denominator is going to have a multiplication symbol also, and then that starts to get pretty confusing with all these other multiplication symbols. So these little boxes are going to end up just being a little bit easier for us. Here's my next conversion factor. I have my numerator on the top. I have my denominator still down here. Instead of a multiplication symbol, I put another vertical bar. And I just keep going. And I get my final answer. Now on the computer, it doesn't really look like it saved any space, but when you're writing these out by hand, it really tends to. It makes it much easier for me to grade your work. You should always be trying to do things in a way that are going to make it as easy for me to grade your work as possible. You want to make sure that, you have the best chance of me understanding what you're writing. All of my answer keys and things will be done using this line method. The other thing that's nice is this line method is a lot easier in the computer, and especially, if you're doing remote teaching and things, you just put a little chart and you can just type your numbers into the chart. Doing the fractions on the computer can be quite difficult. All right, sometimes we have things called double units or derived units, right? When you're combining things together, like miles per hour. If we're going to convert a double unit, we're going to use the exact same technique as dimensional analysis as before, but what we're going to do is we're going to fix the top unit, then we're going to go back and we're going to fix the bottom unit. So let's do an example. We're going to convert 20 miles per hour into inches per second. So you can see that the numerator and the denominator don't match, right? We're going to have to fix both of them. If one of them was fine, great, the problem's half finished. I start with my known value, 20 miles in 1 hour. I'm just going to cover up the bottom and I'm going to pretend it's not even there. I'm just going to worry about going from miles into inches for now. 1 mile on the bottom, 5,280 feet on the top. Miles cancels. I need to keep going into inches, so I'm going to do it again. 1 foot, 12 inches, feet cancels. And right now the top is finished. Sometimes people will forget that they need to go back and finish the bottom. Right now, my units are not inches per second. Right now, my units are inches per hour, which is not what I want. The hour is still left over here. The nice thing is, because this is all multiplication, the order does not matter. 3 times 2 is the same as 2 times 3. So even though the hour is way over here on the left, I can just keep going and it's totally fine. I can still cancel things. So the big difference is if you have something on the bottom you're trying to cancel, you're going to have to put the next piece on the top. So to cancel hours on the bottom, 1 hour needs to go on the top. 1 hour is the same as 60 minutes, so the hours cancel. 1 minute is the same as 60 seconds. Minutes cancel. And now I have seconds on the bottom. So you can see I fixed the top first, and then I fixed the bottom. Sometimes people will ask me, can they do it the opposite? Can they fix the bottom first and then the top? And technically you can, that's fine. But having done this for a long time, what I've noticed is that if people fix the bottom half first, they more often forget to finish the problem. And so I suggest doing the top first and then the bottom so that you're less likely to, forget to finish. Also, that way it will match my answer keys. It'll make it a little bit easier for you to check your work. Okay, take a moment, calculate this in your calculator. What I like to do in my calculator is I put a parenthesis. I say 20 times 5,280 times 12 times 1 times 1, and then close parentheses. I put everything on the top in one set of parentheses. Then I hit divide, and I do it again. I put a new parenthesis for the bottom. I multiply all these bottom numbers together, and then I close up that last parenthesis and hit enter. I feel like that's fastest for me. If your calculator works in a slightly different way and your order of operations is different, do what you need to do. Just be very careful that you're using parentheses to keep the denominators on the bottom. Most calculators are not smart enough to keep the denominators on the bottom when you have a whole bunch of fractions like this. So just be a little bit careful. If you punch that in your calculator, you find out it's the same as 352 inches per second. Okay, last thing here does not come up very often. And there are not a lot of times we need to practice this, which is a problem, because then when it pops up once in a while, people forget how to do it. So maybe make a little note to yourself in your notebook, like, don't forget to study it, or something like that. It is a useful skill, and it's just unfortunately not something that we need very often, but we do still need to know how to do it. So when we have units that have been squared or cubed, right? Like if you have an area, like a square inch, or a volume, right? Cubic foot. These are volumes when they're cubed. We have to be a little bit careful with our conversions. So if I want to convert 5 inches squared into centimeters squared, I'm still going to set up a conversion factor. I'm still going to focus on canceling my inches, but I have to make sure that I square it. So I can't just say 2.54 centimeters over 1 inch. What I need to do is put the conversion factor in parentheses and square both pieces. The really important part is that you need to square not just the unit, but you need to square the number as well. Now, my inches squared will cancel with inches squared. 5 times 2.54 squared is going to give me my final answer, and it'll come out with those centimeters squared. If you were cubing, you would do the same thing. You would put your conversion factor in parentheses, and you would cube the number, and you would cube the centimeters squared. One thing that's kind of nice is that means you do not have to memorize yet one more conversion factor. You don't need to know how many centimeters squared are in an inch squared. If you know how many centimeters are in an inch, you can square the whole thing, and you don't have to look up a new conversion factor. Okay? For the most part, you won't have to memorize very many conversion factors. The ones you will have to memorize will be the ones that are related to chemistry-specific topics. Random ones like inches to centimeters, miles, and feet, those I'll give those to you. I probably wouldn't take the time to tell you things like how many inches are in a foot. I would assume you knew that, or how many seconds were in a minute. But if for some reason you didn't know, you could always ask me that. On a quiz or a test, I won't tell you what the chemistry ones are because you do need to memorize those. And when we finally learn some chemistry specific ones, I'll make a big deal to tell you which ones to memorize. All right, so before we're done with this lesson, I would like you to practice one of the double conversions where you're going to convert the top and you're going to convert the bottom. I'm going to give you one conversion factor that you may not know, and the other conversion factors should be things that you probably know from daily life, like inches to feet, or maybe it's a metric conversion that you should be able to figure out. So since this problem will probably take a little bit longer than normal, go ahead and pause the video and give it a try. All right, so start with your known value. I'm covering up the days on the bottom, right? Because I don't want to deal with that yet. I just want to convert the kilometers. Kilometers cancel. Don't forget that it's there. It's still there. Now meter cancels. Inches cancel. And you'd be left with the foot on the top. Now you can come back and you can worry about figuring out the days. Sometimes people will ask me, well, how did you know that a kilometer had 1,000 meters in it? You didn't tell us that. No, but you know King Henry, and you know that to go from kilometer to meter, you'd have to move your decimal 3 places. And if you move your decimal 3 places, that's the same as 1,000, right? So that's a conversion you can figure out on your own because you need to understand how the metric system works. We'll use those metric conversions so often that you'll probably memorize them on accident. Okay, so now let's worry about the days. 1 day is 24 hours. 1 hour is 60 minutes. Everything on the top multiplied together. And then I put everything on the bottom inside of one set of parentheses, multiplied together, punch it in my calculator, and I get the fact that 30 kilometers per day is the same as 68.4 feet per minute. Okay, the number looks very different, the unit looks very different, but these are the same measurements. They're the same distance, they just look a little bit different. Okay. The other thing that people will sometimes tell me is that they know how to do dimensional analysis, they know how to cancel units, but they don't know how to string together the conversion factors in the right order. They don't know how to figure out which conversion factors to use. It's like they know that the frog needs to hop across the pond on the lily pads, but they don't know which lily pads the frog needs to use to get across. And unfortunately, that's the hard part. There is no trick that I have that can really give you clues on which string of conversion factors to use. The best way to get good at it is practice. The more combinations of conversion factors you're used to seeing together, the faster your brain is going to be able to recall them. Like, I can tell you very quickly to go from miles to feet to inches to centimeters. I can tell you very quickly to go from days to hours to minutes to seconds, because I've done those conversions in that combination enough times. So the more practice you can do, the more combinations of conversion factors you can see, the easier that part will be. Okay? Let's go through, cancel our units, and make sure we did it correctly. Kilometers cancels, meter cancels, inches cancel, and I'm left with feet on the top. Sometimes people get very bothered by the fact that, I might say foot instead of feet. It's all the same, right? Hour and hours. If it's a pluralized version of the unit, it's completely fine. Now we can come all the way back to the beginning and deal with the days we have here. So one day is on the bottom, so I need a day on the top for it to cancel. Now hours and hours, and I'm left with minutes on the bottom. All right, everybody, that's it for this lesson. I hope that was helpful. Bye.